All right. So you did this as review. You should have learned about this in the previous lessons. And what we learned was the force of gravity, if we're talking about feet per second, is negative 16. And we use t for time, so negative 16 t squared. That's the force of gravity. And we add to that the initial velocity, which is 10 feet per second. And we add to that the initial height. So the equation that tells us the height of this spitball is right here. How high will it go and how long will it take for it to hit the ground? So if we think about how it's going to be going up, it's starting at 3, and it's going to go up for a while, and then it's going to come back down and hit the ground based on this parabola. So to figure out how high it will go, we can use our equation that tells us so how high it will go will be at the vertex, and that'll be on the line of symmetry. We have an equation that tells us the line of symmetry is, and that equation is that time will equal negative b over 2a. That's a b right there, b. And b is this term, and a is this term. And so in this case, when we substitute those values in, that means negative 10 over over 2 times negative 16. Negative 16 on the top and bottom, or negatives on the top and bottom will cancel out. So this is negative 10. 2 times negative 16 is negative 32. These negatives will cancel out. And 10 over 32, it equals 0.3125. So it only take like a third of a second for your spitball to reach its maximum height. And how high will it go? We put that number in to the equation. So we put in negative 16 times 0.3125 squared plus 10 times 0.3125 plus 3. And what we get is 4.5, about 4.6 feet. About 4.6 feet. That's how high it will go. And how long will it take to hit the ground? Well, we know it took 3.125 seconds to get there. Now, if we want to know when this when this spitball hits the ground, the easiest way to do that would just be to graph it. So I put it in Desmos, and I'll show it to you. So here it is in Desmos, and you can see that it hits the ground after 0.8 seconds. So it's a pretty wimpy spitball. All right. Hopefully you're able to do that from what you learned before. Today we're going to look at some more word problems with quadratic functions. So I'll work through this first one, and then there's a bunch of them for you to try, and I'll then explain the answers to those, and hopefully you get the hang of it. You're able to answer these word problems using what we know. We are going to use that formula, y equals, or the, rather not y, t equals, or x equals the line of symmetry, right, to find the line of symmetry. I'm writing off the screen. Of symmetry, we are going to use x equals negative b over 2a, and we're going to use that a lot. Alex has a garden with an area of a equals negative 2w squared plus 120w, where w is the width of the garden measured in feet. What width should Alex use to maximize the area? So this is going to be a graph of a garden, something like this, although it should go through the origin. So something like, no, that was a little closer. We're trying to find that vertex. We need to know the x coordinate of the vertex. So remember, these are always in the form y equals ax squared plus bx plus c. And so we are going to take the a and the b and put them into our equation to find out what is the x coordinate. And we'll put the x coordinate into the equation to figure out what the y coordinate of that vertex point is. So in this case, our x equals negative b, so negative 120, over 2 times a, negative 2. In other words, it's negative 120 over negative 4. The negatives will cancel out, and you will get 30. So 30 is the x-coordinate of the vertex. What width should Alex use to maximize the area of the garden? The answer to that is 30. And the area at that point will be given when we put 30 back into our equation. A equals negative 2 times 30 squared plus 120 times 30. And when we plug that into a calculator, we get 1800. So the answer here is 1800. You could also have solved this by putting this equation into a graph. Desmos would have worked great. But finding that axis symmetry is going to allow us to find a maximum and a minimum, knowing that when the a term is negative, our parabola is upside down will help us know if we should be finding a maximum or a minimum. Let's take a look at the next problem, and then you guys can give it a try. Here we have a population of bunnies, and the observed bunny rabbit population on an island is given by the function negative 0.4 t squared plus 130t plus 1200, where t is the time in months since they began observing the rabbits. When is the maximum population attained? So our graph will look something like this. This y-intercept is going to be that 1200. We want to know what are the coordinates of the vertex. So of course we need to find that line of symmetry. Make sure you use your equation, x equals negative b over 2a. And good luck, and then I'll see you with the solution in just a second.